In this tutorial, we're going to discuss screen space reflections, how these work and how we can control them. So you can see here I've got 3 spheres in my scene, each with kind of different levels of roughness. Now all of these are reflecting obviously this shape, the surrounding environment and the sky map up there. All of these reflections are generated using screen space reflections. There's no reflection probes or anything in this scene. By default, screen space reflections are turned on anyway. If we just select our process volume and see how we can control these, you can see I've just put SSR here so that I can see the options available. I have intensity, quality and max roughness. We might as well put our quality up to full for a start. And we'll leave our intensity on 100. Now max roughness basically refers to how rough is the object before it starts, before screen space reflections aren't used. Now these are quite expensive. It's fine for PC, but when you're using this on something like a lower end hardware, mobile, switch and so on, if you're using these at all, you'll want to have your max roughness kind of reasonably low to save resources. You can also turn these off completely just by entering 0 into here. Okay, so we're going to keep these two set like this, and we might as well put our max roughness up a little bit higher as well. Okay, so they look pretty nice, and the good thing about them is they reflect moving objects too, so that for our animated scenes we'll be able to see reflections on our surfaces. But what are the downsides of these? Well, the main downside is their screen space. So the way they work is they take anything that's on camera and generate a reflection map of that. So as soon as something's off camera, it's not going to be part of the reflection generation anymore. So for example, if I just rotate around here until that is off screen, you'll see how that giant red object is no longer in the reflection. Obviously bring it back on camera and it's back in the reflection again. The other real downside is it's quite expensive to use, not too important for this assignment. And I guess the last downside is you can get a little bit of kind of pixelation and so on, so a little bit of artifacting kind of around there. But other than that, that's kind of the limits. Really easy to use and so on. Of course, we do have reflection probes as well. The problem is that reflection probes can't pick up dynamic objects, so they're not an ideal solution for this project. I'd imagine most of you will be using just screen space reflections. So if we just build our reflection capture though, and then say on this object here, we'll assign this, and then we'll just nip to our post-process volume and put our intensity on our screen space down to 0. You can see the reflection probe hasn't really captured anything because there's nothing for it to capture. So yeah, what you'll be using primarily is screen space reflections. You can use reflection probes, but the way you'll have to use those is by capturing an image of your scene and using that as like a specified cube map. So for example, if I took all these objects here and our red thing here, and we set these to static instead, and then did a build of this. Obviously it's going to break the scene a bit, but it will mean that we can get something nice for our reflection captures. So yeah, primarily we're going to be using screen space reflections anyway, but I do want to show you that it is possible to use our sphere reflection captures. It's just that you have to kind of hack your way kind of around it a little bit. You can't just use them as you did in previous projects because they only work with static things.